Okay, so let's just dive right in. For decades, we've been on this quest to build machines that are truly intelligent. But that raises a pretty massive question. How do we actually know when we've done it? I mean, how do you measure a mind? We've been using games and benchmarks for years, but as you're about to see, we might have been measuring the wrong thing this entire time. And this quote, wow, it really gets to the heart of the whole mystery. It comes from right after a super famous moment in AI history, and it points to this deep, lingering problem in how we even think about what intelligence is. A lot of us probably remember this. I mean, it was a huge deal. A machine beat the world's best human at chess. It felt like the future was here. But pretty soon, researchers realized that even though Deep Blue was an amazing chess player, the knowledge used to build it was basically a dead end. You couldn't use it to solve any other kind of problem. And that, right there, is the central question for us today. If just pure performance on a really complex task isn't the answer, then we have to go all the way back to the drawing board and ask, what does intelligence really mean? Well, to start solving this puzzle, we can actually borrow a key concept from human psychology, and that's the crucial difference between a skill and an ability. Now, they might sound like the same thing, but believe me, they are fundamentally different. So a skill, right, like playing chess, is all about performance on a specific task. It's about what you can already do. But an ability is much broader. It's not about what you know. It's about how efficiently you can learn brand new things. So the real measure, then, isn't just performance. It's the efficiency of the learning itself. And the key ingredient of any true cognitive ability is this concept: generalization. It's the power to deal with new things, with uncertainty. I mean, a system that can only solve problems it was explicitly programmed for isn't really generalizing, is it? True intelligence is all about adapting to the unknown. And think about it, this is exactly how we've measured human intelligence for over 100 years. IQ tests, they don't just measure one skill, they use a whole battery of new unfamiliar tasks, because the goal is to figure out that underlying ability to learn, not whether you studied for a specific test. So, you know that old problem from the world of chess? Mistaking a specific skill for broad intelligence, well, it's still with us. It never really went away. We've just swapped out the chessboard for new kinds of digital benchmarks. In today's world of large language models, benchmarks with names like Glue and SuperGlue became the gold standard, and they use a whole collection of language challenges, kind of like an IQ test. On the surface, it seems like a step in the right direction, but they have a fatal flaw. And what's that fatal flaw? The tests are public knowledge. Everyone knows what's on the test. This lets developers train their models on very similar problems, basically teaching them how to ace the test. The system isn't really learning efficiently. It's just being gamed. We're right back to measuring a specific skill, not a general ability. And this really makes you stop and wonder, doesn't it? If we're just building systems that are incredibly good at passing our benchmarks, are we actually making any real progress toward genuine intelligence? Or are we just creating some very, very sophisticated parrots? Okay, but this is where things start to get really exciting. All this dissatisfaction with these gameable benchmarks has led to a completely new approach, one that's designed from the ground up to measure true, generalizable intelligence. So I want you to meet the Abstraction and Reasoning Corpus, or ARC for short. It was developed by a researcher named Francois Chollet, and it's built on a formal definition of intelligence as skill acquisition efficiency. It's not about what an AI already knows, but how quickly and efficiently it can learn something totally new. So how does this thing actually work? Well, ARC gives an AI a bunch of novel visual puzzles it has never seen before. And with just 2 or 3 solved examples, it has to figure out the underlying logic and then apply it to a new one. The crucial part? The tasks are totally unknown to the developers, which prevents anyone from gaming the test. It's a direct measure of the ability to generalize from almost nothing. So, the big question? How have today's top-of-the-line AI models performed on this test? The answer is 0. That's right. To date, not a single machine learning technique has been able to successfully solve the ARC challenge. It just goes to show you, we still have a long, long way to go. Now, when you shift how you measure intelligence, it also completely changes how you build it. But creating a true blueprint for a reasoning mind, well, it has a dark side. Because if you know how to build a mind, you also know how to break one. For instance, instead of just making existing models bigger, researchers are now designing systems inspired by cognitive neuroscience. This one architecture, LLM-PFC, actually tries to mimic the functions of the human brain's prefrontal cortex, the part that's our center for planning and reasoning, to help language models solve really complex multi-step problems. And this isn't just some abstract theory. The process uses different modules. First, a task decomposer breaks a big problem down into smaller pieces. Then, a search loop explores solutions for each of those little pieces. And finally, an orchestrator watches over everything to monitor progress. It's a genuine blueprint for a reasoning mind. And that brings us to the flip side. Understanding how an agent plans and decides also shows you exactly how to attack that process. This is something called reflexive control. It's not about using force. It's about feeding your opponent manipulated information so they willingly make a decision that you want them to make, all while thinking it was their own idea. And this is not science fiction. These exact principles have been used in real-world information warfare for years, from the cyber attacks in Estonia to creating economic dependencies in Georgia. The goal is always the same: manipulate the information an adversary sees, and by doing that, control the decisions they make. And this is the ultimate goal of it all: decision dominance. It's the ability to sense what's happening, understand it, make a decision, and act on it faster and more effectively than your opponent. It proves that the modern battlefield isn't just physical anymore, it's cognitive. So, let's try and bring this all together. From chess-playing machines to the blueprints of cognition and the battlefields of the mind, this whole journey reveals something really profound about our quest for artificial intelligence. Because every single time we try to define what intelligence looks like in a machine, we're forced to turn around and define it in ourselves. To build an AI that can truly learn and reason, we first have to really understand how we do it. And in that way, the technology becomes a kind of mirror. And this is the thought that I want to leave you with. As we keep building these increasingly complex systems that reflect our own cognitive processes, what are they ultimately going to show us about the nature of our own minds? What parts of ourselves are we going to see more clearly for the very first time?